because she always seems like she's like, I don't know, just kind of here, maybe not here. She doesn't seem, I don't know.
Yeah, I don't know.
Got a lot.
Hopefully she's able to come here Thursday. But
Yeah.
you asked me if I had any trouble with the prepared assignment. So at first I did. So I took notes. I took notes on the lesson, and then after that I went through the prepare, and the questions were really confusing me. So I went to the answer key to see if I could like understand it. You know, like you look at the answer key and then you find it in the question. Once I did that, though, I understood what they were asking, and I was like, oh, okay, now that I know what they're asking, I can figure out the answer on my own.
For more or less, I think for the most part, it's all that same. It's all the same. I'm trying to look for it really quick. It's all the same equation, more or less, where you work on the same thing. So I have all of mine done, very honestly, except the very last one, number 13.
Number 13.
Where you, well, I'll be honest, I have it. It's not super clear to me using that margin of error equation. So it's one of those things where I got the answer, but it's like, oh, I have the answer, but I'm not entirely sure how I got to the answer. So I figure we'll be okay. The rest of it, I very honestly, yesterday was probably the first time I did some of the work, like the prepare, where I felt like I actually understood what I was doing and didn't feel like I was off in the weeds somewhere.
That's funny because what was it, last week's lesson about the hypotheses or whatever? I really understood it. And I was like, okay, I totally get this. But this week I'm like, what do I do with this information?
I literally watched the prepare questions where they break them down one by one, and that I watched it twice, and I was like, okay, I get it. And I was like, oh my gosh, I get it. So
I'm going to talk to my husband and see if he understands this week's lesson. And if not, because I mean, he's in Mass 221A and I'm in C, but so far our lessons have lined up exactly.
Oh boy.
Weird, because his is for business and I'm like a psychology major.
That is weird that they're different like that.
It is.
Let me see what we got going on here.
Anyway, so yeah, I might have to go through those videos and like help me understand it, because yeah, I have all these formulas, but like you said, it's like the same thing.
Yeah, I think like doing the same thing over and over.
Do what?
It felt like we were kind of doing the same equation over and over. So yeah. So
yeah. I feel like... Go ahead.
No, go ahead. Go ahead.
I was gonna say, I feel like the most important thing that I took away from the lesson this week, or this first lesson, is that it's just when you're changing the confidence level, and knowing how to do that, when to plug in the Z-score and when to use the 95%, if that makes sense.
Yeah.
But other than that, like you said, I think everything's the same.
Yeah, it felt pretty comfortable once you got started with it.
Yeah.
So, okay. Do you want to go ahead and try to do the quiz?
Yeah, 1 second. I got a message from Hyla. She said I'm not sure how to do the video call, so I'm going to tell her that I sent her the link. So I guess she's not sure how to get on.
I know she's had a hard time with that part of it.
Yeah. I feel bad because some people it comes naturally and some people it's just really difficult to figure out.
I agree completely.
My dad, he works with computers, so all my life I grew up with technology and like fixing things on my own.
Well, and well, and Hyla and I come from an era where we didn't have I didn't have like laptops and cell phones in high school.
Right.
I'm that old. So, anyways, and some days it feels even older. So hopefully, Hyla.
Okay, so I am not in the right course. I'm in biology right now. Oh, did she send me a message? Okay, I received a video call, so she should be here in a minute.
Okay, awesome.
So I need to get to the math course.
I know.
Yeah.
I have all these windows open and I'm closing everything. I'm like, don't need this, don't need that.
I'm just like praying my thing doesn't drop out because of all my tabs.
I'm always afraid I'm gonna start closing stuff and click something, and we'll be another 10 minutes while I try to figure it out. Okay. So I am ready. My group meeting quiz is not open, but it's pulled up.
Say, I just opened mine.
Hi, guys.
Hi, Hyla.
How are you guys?
We're good. How are you doing with the new stuff, Hyla?
Okay, I don't think it's as bad as what the previous part or previous unit was.
I think I agree, because I was like so excited last night because I got it all. First of all, I got it all done. But the second thing was, it was like, I got it done and I understand it.
Yeah.
That was the interesting part.
Yeah. The last quiz that we took, I took it twice.
Mm-hmm.
And the first time I did really bad on it. And the second time I only missed one. I'm like, okay.
I think I'm getting something. Yeah, there you go. So, okay. So we were talking about getting started on the meeting quiz.
Okay. Sounds good.
Are you ready for that?
Yeah, I'm just getting it up.
Okay.
I got a video chat or a video call from you, Emily, but nothing else had come up.
Oh, that's weird. Yeah, so I like when I pull it up, I invite people from the Hangout screen just because it's easier. You have to add a person. It's kind of weird today, so yeah, that's odd.
Emily, you're in Rexburg, aren't you?
Yes, I am.
I heard my daughter lives there. I heard it's cold.
It went from summer to winter. We have no fall at all.
That's what she said. She lives in the apartments behind G's Dairy, or kind of around the corner from G's Dairy.
Oh, okay, yeah, that's kind of where all the married housing is. I live right across from the water park, so.
Oh, very exciting.
Right by. Yeah. The water park that's open for 2 months out of the year.
Well, yeah, and that we had that conversation earlier because she just found out she's pregnant, and she's like, "Well, no water park this summer." I was like, "Well, you'll be done by that. You know, we don't have like the elephant length of a pregnancy, so you can you'll make it to the water park if you want to this summer." So, anyways, okay. So let me open my. Should we open our quiz?
Yes.
Sounds good.
Okay, here we go.
Is there a link to the applet? Yeah, there is. So find the margin of error.
Find the margin of error for 9.0.
I'm on the wrong page. Okay, so does everyone have the first two checked?
Yes.
Yes.
All right, so number 3, find the margin of error for a 90% confidence interval when the standard deviation is equal to 50 and n equals 25. So we use the margin of error formula, right?
Yes.
Okay.
So it's, where's my calculator?
250. What would you call n? Is that like the sample? Because that's what we called it in like the last lesson, but I don't know what to call it now.
N is the sample size.
Sample size? Okay. Just like for future questions.
Oh, whoops. I'm writing things in the wrong spot.
We know. So if it's
I always screw up. Is it 50 divided by 5 or 5 divided by 50? It's 50 divided by 5.
Yeah.
So it's 1.6.
Okay, I'm confused because.
So the equation would be z times sigma over the square root of n. So I wrote it out as the z-score for 90% is 1.645. So I put 1.645 times 50 over 25 because your 50, your n is 25.
I see what I did wrong. So I put 2 times the stuff that's divided by 2 because that was the first equation it gave. So no, anyways.
And that's where I got screwed up. And so then the square root of 25 is 5.
Oh crap, I forgot to square root that.
And then so where I always get confused is like 4th grade math. So is it 5 divided by 50 or 50 divided by 5?
I think it's 50 divided
by 5. Yeah.
Okay, so 50 divided by 5 is 10.
10.
So it's 1.645 times 10.
So did you get 16.45?
5 times 10 is 16.45.
That's what I got.
Okay.
My number. So it would be 450, so you have to run to 3 places.
Yes. 16.450. Because it says round to 3 decimal places.
Got it.
And then question 4, which of the following statements is true? And this is where I'm going to be scrambling through our chapter because this part gets really... Is it sigma squared is an interval estimator of bar x? Bar x is a point estimator of mu. Mu is a point estimator of bar x. Or sigma is an interval estimator of sigma squared.
Where did I put? No, that's not. No, that doesn't make sense. Okay.
Let's read the range of possible values for parameter.
In the notes.
If you in the text information under 3.32 is where it's going to. So if x as a normal, x is a normal random variable with mu and standard deviation divided by square root of n. That does not help me. So one of the things it says is if the original population has mean and standard deviation, then the sampling distribution of x will have mean and standard deviation. So
let's see. You said, because I think I'm looking at the same place in the book.
the 3.3.2.
Yeah.
Let's see. If we collect a random sample.
Estimator. Point estimator. Or it could be a point estimator. That's all the same because it's just. Oh. Because I wrote down that I don't think it relates to it, but I wrote if x is within 2 standard deviations of u, then u is within 2 standard deviations of x. But I don't think that'll.
I'm looking at the same thinking, how does this work? Okay, so I think number 2 and number 3 sort of cancel each other out. I don't know. But actually they all look, I don't know. This one I am kind of lost on. Okay, so one of the things it says is, the short answer is we will never know if x is close to mu. So,
Right.
So we know the second one, x is a point estimator of mu, is probably not true from that.
That's true. Yeah.
So maybe what we can do is go by a matter of just deductive reasoning. Let's see. So we know 2 is not. Mu is a point estimator. Mu. 3.3 of the population. Okay, so maybe if we take out. Okay, so let's do it this way. Standard deviation squared is an estimator of the observed data point. Mean of the population is an point estimator. Oh, wait a minute. Sorry. Observed data. Wait. Mean of the population is a point estimator for the observed data point. Or standard deviation is an interval estimator for standard deviation squared. Oh, crud. All of a sudden my cell phone rings. I'm like, no! Range possible. What about the last one, where the standard deviation is an interval estimator for the standard deviation squared? Because an interval estimator is a range of plausible values for a parameter.
That's what I was kind of thinking.
And where was that? Where were those last couple of sentences you were reading from the book?
In the 3.1, 3.2.
Okay.
3.1, 3.2.
In the very beginning of the chapter.
Oh, okay. Yeah, I think, yeah, I'm going to agree with you. I think it's the last one.
Okay.
Me too.
Okay. Let me be a better person and turn my ringer off on my cell phone. Okay. So I'm sorry, you guys. Okay, so Gina wants to construct a 95% confidence interval for scores. She knows the standard deviation is 113. Collects a simple random sample of size 64. Computes bar x as being 526. Uses information for the next 6 questions. What is the point estimate? The point estimate. Excuse me. Wouldn't the point estimate be bar x 526?
I think it is. I need to those questions.
I grabbed my notes here real quick.
Because yeah, that was one of those questions on the prepare sheet that I understand what they were asking.
Let me look at my prepare sheet and see.
Point estimate is plus or minus the margin of error.
What does that mean?
Wait a minute. Point estimate is plus or minus this margin of error?
That's what I have.
So it would be, so the point estimate would be 113 if it's margin of error. Point estimators are one number that is used to estimate the parameter. Parameters are generally unknown values. Think about it. Think about the mean. If U is unknown, how do we know if X is close to it?
I think it's 526 because in the prepare assignment, it says on number 7 it says was the point estimate for the population, and then in the it says the mean for these students is 541, which is X.
They took the X. Okay.
Yeah, I
So the
think
point estimator is the X.
Does that make sense to you, Hyla?
Yeah.
Okay.
I'm taking notes. What is the margin of error for the 95% confidence interval? So the margin of error, so we take our margin of error, which is Z times O over the square root of N. And the Z-score for 95, wait a minute. The Z-score for 95% is 1.96. So it's 1.96. Sorry, I talked myself through everything.
No,
That's okay.
I did the same thing. I think I was really annoying in high school.
And then it's 113 over, oh. Hello, pencil. You can die now. That's fine. That's real convenient today. Oh, I broke another one. Square root.
13 over 64.
64. Oh my gosh. And the square root of 64 is 8.
So I got 27.685. Let me know if you guys get the same.
Okay, give me
Good.
1.2. 7, 6, 5.
What did you get again, Emily?
Emily, did you say 0.0223?
No, I said 27.685.
That's what I got.
Wrong.
What did I do wrong? I did something wrong. It's probably my division. I have this problem.
Per value, say so 1.96 times 113 divided by 8.
Oh, that's what I did wrong. Oh my gosh. I just found my mistake.
What did you do?
I didn't do the square root. I just used the 64.
Oh.
I did that the first time with that other problem.
$27.685.
Yep.
Yes.
There we go. That's the answer I got. And if you want, here, it's on my calculator right there. I didn't cheat.
We believe you.
Okay. What is the lower limit of this confidence interval?
You have no idea what that means.
Limit? Well, don't say that because I was looking at it thinking the same thing.
When I'm looking at the prep sheet, I'm like, please tell me and ask that. What lower limit?
the lower limit of this confidence interval. This confidence is commonly used interval estimator. This reading will explore how to create an interval.
Lower limit.
Confidence intervals. Okay. Oh. This is the bar x minus the z-score times the sigma. This is that other, you know, where you were doing the plus or minus during the homework?
Mm-hmm.
This is that.
Yes,
This is that equation. So the lower limit would be the -1.
Okay.
Does that help?
Yeah.
Okay. So 5.
What did it say it was? X.
What is 3 minutes?
526. I got 523.2315. So let me see.
Give me just
No, you're good.
what did you get, Emily?
3.2315.
Okay. I got 498.315. 498.315.
I could have done it wrong. So
I did 526 minus 1.96 times 14.125.
times point. Where did you get that last number from?
The 14.125.
Mm-hmm.
When we did the factor, oh, you know what? No, I didn't. When we did the factoring for the 95%,
Mm-hmm.
the O over the square root of n
Mm-hmm.
was 113 over the square root of 64,
Mm-hmm.
which came out to be 14.125. So instead of factoring it again, I just grabbed it.
Okay. Okay, I see what you mean. Yeah. Because I'm just doing it all on my calculator, so I'm just doing it all at once instead of breaking it up. Okay, so let me see. 526. And then you said minus, right?
Minus, yeah, because you want the lower number.
So minus 95 is 1.96. 1.96 times, let's see.
14.125.
I don't know what you got this time. I have no idea what I did wrong. But anyways, okay, I did it slowly this time and I got what you said, 498.315.
315, yeah. Sometimes when I run it all at once, the calculator separates it differently than the equation is set up, so it doesn't come out the same. So now it wants the other end. I should have known.
So, that's 5.
So 526 plus 5. I got 550.685.
You said 553.685.
550.5.
Let me try it again. So 526 plus 1.96 multiplied by 113 over the square root of 8 multiply equals. I still got 553. I don't know what I did.
685. Let me do it again. I got 553.685. I did something wrong last time. Probably.
Oh yeah, that's what I got.
So I feel like since you already had that answer, we're gonna. So
go for that.
what would happen to the width of the confidence interval if she increased the sample size? And that is where this was on the prepare. I remember it. Oh, where is it? The margin of error gets smaller as the sample size grows larger.
So it would decrease.
So what would happen if the width of confidence increased? If it increased, when the increases, the sample size increases. Is that what I said? Did I say something different? Yes, when one gets bigger, the other gets bigger. When they get smaller, margin of error gets smaller, confidence gets smaller. Margin of error, wait a minute. How does the margin of error for any confidence interval? Okay. Hey, Hyla, you want to do question 10?
Okay. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
What would? Well, I think I just confidence interval.
Would it increase?
Margin, wait a minute.
You're going from a 95 to a 99.
So the confidence is getting larger?
Yeah.
So the margin of error would get larger.
Okay. Right.
That's off of one of the last prep questions. Oh, we're 3 questions away. 1, 2, 3.
Oh, 4.
No, 4. I don't always count well.
Okay. So what we're looking at. So when it says, what would happen to the width? So what are we looking at when we compare to the 99% interval?
I was looking at on question 12 on the prep. Mm-hmm. When the margin of error is smaller, the confidence gets larger. So when the margin of error gets larger, the confidence gets larger.
Okay.
That's where I pulled that from.
Mm-hmm. Okay.
So,
that makes sense.
Okay, so we're at question 11.
Okay. Brightbulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Whew, bug.
So let's see. 5 is sample size calculations. Tells the number of, okay, so there's a formula for it. So it's 95.
Sample size calculation. The trick is to solve the margin of error equation. So it says you would do the z times the sigma over the square root of n for n It gives a sample size formula which tells the number of observations required, which is n equals z-score. This is the n equals z-score times 0 over m squared. 95 is 0.96.
That's the answer, 95.96?
No. Standard limit.
Equal divided by
400. The calculator keeps turning off.
$95 is 0.96. I got 245.862.
Okay, my answer is wrong.
I don't know.
Because I have 246.
Oh, really?
Yeah, so, because what equate, I did the z times
The standard deviation over m squared.
Which,
Yeah, that's what I did.
okay, so what did I do wrong? So it's 1.96 times 400 divided by 50, which is 15.68. And then, oh, wait, what did you get originally?
245.862.
Okay. And then I said 246 because you round it, period. You round it.
That makes sense. I wasn't looking at that.
That's okay, but that's what the difference is.
Okay.
And you know what? If we can figure that out, then we're moving in the right direction. Okay, 3 left.
All right.
Oh my gosh, I feel like I actually might understand what I'm doing. Okay. The mean salary of actuaries is 100,000. And the standard deviation is 36,730. I need a different job. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set a hypothesis test with a level of significance being 0.05. And the null being 100,000, the alternative being not 100,000. You collect a simple random sample of 36 women's salaries, finding that X equals 111,000. Use this information for 3 questions. What is the lower limit of this 95% confidence interval? So
X equals 111.
1.96 is your Z. Lower limit. So this is the plus or minus thing.
Yes.
Okay, so X is the 111,000
over the square root of n, which is 6.
minus 1.96.
Holy crap, that's a huge number.
What was, oh, n is 36. Oh, this is going to be giant. I haven't done it yet. And I'm like, oh, this is going to be a big answer.
Yeah.
Okay, so the square root of 66. So 36, 730 divided by 6 equals. Okay, so 6121.666. Gotta get a regular pencil. Cool. I got 99,001.
Crap. There's something wrong.
Or actually be 99,002.
I got 109,100, so I did something wrong. So, did you take the X that's 111,000?
I did. I did 111,000 minus 1.96 times 36,730 over the square root of 36.
Which is 6, so I get... What the heck? I swear I just did this exact equation, and now I got the answer that you got. That makes no sense to me. I swear I did the exact same thing. Maybe I'm just working too fast. I bet that's what I'm doing, and I'm not paying attention.
I actually think that would be it. So the answer would be 99,001.
Right. But do we need to round it to 99,002?
Oh, yes. So the answer would be 99,002.
I swear I did the exact same. Whatever. I'm just gonna. It says the right number on my calculator.
So now they want the other thing, the other direction. So I would just add 111,000 plus 11,998.4653, which is, I got a giant number, 122,999.
1 second. No, wait, oops, wrong one. Maybe I didn't put the decimal in that time. I don't know. Okay. Over.
Oh.
Okay, so what did you get?
I got 120. Wait a minute. 122,999. Because I rounded up.
Okay, I see what you did. You just rounded up the 4, yes. Which rounds up.
Yeah.
Okay. 2.
Hello? Okay. So question 14 is the last one.
I'll read that.
Okay.
Go for it.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample was drawn from a population. Sigma is known. X bar is normally distributed, and all of the above.
So I'm gonna.
According to 4.4 requirements in the textbook, it is all of the above.
That's what
that's what I would say.
Okay, guys, we are done.
Oh no, are you late, Jen?
It's okay. It's okay.
Okay. Feel bad.
I know that nowhere in the ecclesiastical endorsement does time showing up in a timely manner count, and my bishop is usually late. So I'm not worried. Oh, we missed question 4. We missed that one where we weren't sure.
I'm okay with that.
Oh. I got a 85.71. I'm good with my grade. But what I don't understand is a bunch of these say half point.
Mm-hmm.
I know.
Wait,
Oh, because it was only worth half a point. I get it now.
what did you get at the bottom? What's your score?
85.71. It says I got 12 out of 14. I missed number 9.
Number 9. Because I got 13 out of 14.
Well,
I put decrease for number 9.
yeah. And you know what? I almost feel like I marked it wrong. I'm not going to worry about it. I'm not going to worry about it because I got 12 out of 14.
Yeah, no, that's good.
And I feel like I have been off in the weeds so bad. And I knew my formulas. I knew what I was doing. I feel really good about it. So I'm more than happy with that. And then Kyla, I told Emily that I would be responsible for next week for Thursday's group meeting. Okay. Okay, guys. So
Sounds good.
I will see you all on Thursday.
Okay, we'll see ya.
Bye.
Talk to you later. Bye.
Bye.